All right, welcome back, boys and girls, to the drive-through, one of the most challenging DTCs that I've ever been, I guess, forced to do. Okay, this is law of signs, ambiguous case. All right, anyone know what the word ambiguous means? It means not clear or undefined. Okay, the thing about this is that there might be two triangles that meet these requirements. There might be one triangle that meets this requirement, or there might not be any triangles that meet this requirement. And we are stuck at the beginning figuring out that. How many triangles are there? So, actually, let me do this. We know that angle A is 50 degrees, okay? I'll call this B up here. We know that, I'm sorry, I won't call that. I'll call that C up there, sorry. We know that somewhere over here, somewhere, we have no idea where it goes, we know that side A is 34 degrees. And then somewhere down here is B, and we know that side B is 40 units. What we have to do is compare the side across from the given angle, so we have to compare side A to the height of this triangle to point C. How can we find the height? This is where you guys talk. How can we find it? Sine, good. Okay? So we would say sine of 50 is equal to h over 40. So h is equal to 40 times the sine of 50. Now I want you to look at your papers. Do you see somewhere where it says compare B sine of A to A? Can you see that? Notice, this is B sine of A. I'm going to need somebody that's got a calculator handy to help me out. So Caitlin, can you do 40 times the sine of 50? Okay. So H is 30.64. All right, now here's what I want you to try to understand. Notice that H is less than A, okay? And that A is less than B. If you can think of this blue line as something that's just swinging in the wind, do you recognize that it's going to hit this dotted line AB at two different places? And that's why there's two solutions. So I'm going to clear this board momentarily and draw a bigger version of what's actually happening. We have this acute triangle, or acute angle, where we have a 50 here, a 40 here, was that 34? Okay, and then this side here is unknown, this is unknown, and this is unknown. You follow me on that? But we have an additional triangle. So we still have a 40 unit side there. And we still have a 50. Okay, but if you notice on this picture, the blue line could also hit right there. Do you follow me on that? So in addition to this nice normal looking triangle, we have another triangle that's kind of weird looking that looks like that. Now, can you guys, do you realize that this triangle is ASS? Do you realize that? The given information in order is ASS. S, S. Was that one of the ways we had to prove a triangle congruent to another triangle? It was not. This is why. Because there exist two triangles with the given information, and these two triangles are clearly not congruent to each other. Does that make sense? And so now we are faced with the goal of solving both of these triangles. So, oops, that's the wrong way. So, since B sine of A, okay, is bigger, is less than A, and A is less than B, now we know that there are two solutions, okay? This is really the hardest part, and we're going to do more of them, so you'll feel better about them. Just stay with me. So the first step to this process is figuring out how many solutions there are. We'll do others where there are no solutions and where there are two solutions, or sorry, one solution. But keep in mind, do you know what would make no solutions? If this A was smaller than the H. Because then the A, if let's say the A was 20, it would just be swinging in the wind. It would never hit the bottom. Can you picture that? So that's the situation that we would have no solutions. And then if the A was the exact same length as the H, if it was 20.6, then it would only hit at one point, and then we'd have one solution. So we're going to get better at that as the day goes on. Okay? You follow me? How many solutions does this have? Two. So what we do now is we just write down what we have. So A is 50. A is 34. B is 40. There's going to be two different angle B's. Let's go back to our second picture. This is angle B. That angle B will be acute. This is also angle B, and we'll call it B1. What's this angle B look like it's going to be? Obtuse, okay? So now we have to write down B and B1. Okay? Now, we're also going to have a C and a C1, because as this angle B changes, this angle C will be different. And therefore, we're also going to have a C and a C1. You still with me? You're going to have to focus harder than you probably ever have. Now, how can we find this angle B first? Anyone know? Jamin? Excellent. So sine of 50 is to 34, like sine of capital B is to 40. Okay? Now, when you cross multiply and divide here, you're not done yet, so be careful. You're going to have sine of B equals, and you multiply that way, and then divide that way. Can you do that for me, Caitlin? Do 40 times sine of 50, hit equals, and then do divided by 34. What do you get?
0.9.
Keep going.
0, 1.
Keep going. Okay, good. That's good. We're going to go 4 digits on that one. Now, how do we get rid of sine? Sine inverse. So do second sine 0.9012, or second sine answer, and what do you get for capital B? Okay, now these directions tell us to round our angle to the nearest degree, so we're going to call this 64 degrees, okay? So, how can we use that information to find angle C. Subtract from. So we'll do 180 minus 50 minus 64. And what do you get for that? 66 degrees. Okay? Now, I know we could find little c right now, but we're going to stay focused on the angle. Do you see these two blue lines right here in our picture, the original blue lines? How are those two blue lines related to each other? They're congruent. So what type of triangle is this blue triangle? It's isosceles. So, if you can imagine, the other one would be right here. We just found that this is 66 degrees. So what's this one? So then how do we find B2, which is right here? That's right. It's the supplement of B. So this B1 is the supplement of the B we found. Okay, so let me go back to this screen. So what is B1 then? One supplement of this one. 116? I think it's 116. So then what is C1? 14? No, it's not the supplement of C. To find C1, we got to do 180 minus A minus B1. Does everybody understand what we're looking at right now? Okay. So now, how can we find C? Jamin, do it the same way you did last time you volunteered for something. That's fine. You call it whatever you want. Sine of 50 is to 34, like sine of 66 is to little c, not little c1, but little c. Now you can just do this, right? Your calculator. You do 34 times the sine of 66 divided by the sine of 50.
40.54.
Okay, now look. For 64 degrees, we got an answer of 40. So does it make sense for that 66 degrees, we'll have an answer of 40.5? You can check yourself throughout this entire process. All of your answers should make sense. Okay? Now how are we going to find C1? Jamin? Keep sinning, baby. Sin of 50 is to 34 again, like sin of 14 is to C1. Excellent. Because angle A, the question being asked is, how come C1 is 14 and not the complement of C? Okay? Well, if we look at our picture, this is C up here. We were given A. We found B first. C is just 180 minus A and B. Okay? Or another way to look at it by looking at the pictures, C can't be obtuse. It's only B that can be obtuse. And remember that only one angle in a triangle can be obtuse, not two. Okay? Is this the right picture? It's not? They're starting to look so similar. There's different colors. Okay. So, that's crazy. There's like, I have no method to my madness, but I do in some sense, because I did all of this ridiculousness in the same order. Alright, so now we're here. How do we solve for C1? 34 times the sine of 14 divided by the sine of 50. You're going to have to practice putting that in your calculator right, or you're going to screw it up on the quiz. What do we get, Caitlin? And that is one of the hardest things I could possibly teach you guys. So we're going to spend the rest of the day practicing and getting help. Okay? It's just up to you to work and ask for questions. Boom!